Take a deep, slow breath and feel your body settle into the surface beneath you. Allow the gentle weight of gravity to anchor you as we begin our journey into the quiet, powerful rhythm of the ocean tides. Imagine yourself standing at the edge of the sea as twilight begins to paint the sky. The air is cool, carrying the clean, salty scent of the vast water before you. And here, at the boundary of land and sea, you are a direct witness to one of the most profound and reliable rhythms on our planet. This rhythm, this ceaseless breath of the ocean, is governed not by wind or weather, but by a silent, cosmic dance. The primary choreographer of this dance is the moon. What's fascinating is that the moon's gravitational pull doesn't just pull the water on the side of the Earth facing it, it pulls on the entire planet. Because the water is fluid, it responds more dramatically, creating a bulge, a high tide, directly beneath the moon. But here is the truly remarkable part. A second, nearly identical high tide forms on the exact opposite side of the Earth. This happens because the moon is pulling the solid Earth away from the water on that far side, leaving it to bulge outwards in response. So, at any given moment, our planet has two high tides, two vast, silent crests of water drawn out by a celestial partner over 238,000 miles away. As you stand there, you feel the first touch of the incoming tide. A thin, glassy sheet of water slides up the sand, whispering as it comes. It reaches your bare feet, and the coolness is a sudden, pleasant surprise. It's a coolness that speaks of the deep ocean, of depths untouched by the sun's warmth. The water swirls around your ankles for a moment, and then, with a soft sigh, it recedes, pulling countless grains of sand with it. This is the pulse, in and out. A cycle that has been repeating for billions of years. And this pulse has a very specific tempo. Most coastal areas experience what is called a semidiurnal tide, two high tides and two low tides each day. But here's something most people don't realize. A tidal day is not 24 hours long. Because the moon is also orbiting the Earth in the same direction that the Earth rotates, it takes our planet an extra 50 minutes to catch up to the moon's position each day. This is why the high and low tides don't happen at the same time every day. They are consistently about 50 minutes later. It is a clockwork universe, but the clock runs on lunar time. Feel another wave slide a little higher this time, the water now covering the tops of your feet. The sound is a gentle, rhythmic shushing. It is the sound of immense, slow power. This power isn't always the same. Twice a month, during the new moon and the full moon, something special happens. This is when the sun, the earth, and the moon fall into a straight line. The sun's gravity, while weaker than the moon's, still exerts a significant pull. In fact, it is responsible for about 46% of the tide-generating force. When its pull aligns with the moon's, they work together, creating higher high tides and lower low tides. These are called spring tides. You can almost feel it now, a sense of greater energy in the water, a more ambitious reach as the waves foam a little further up the beach. Then, 2 weeks later, during the first and third quarter moons, the sun and moon are at a right angle to each other relative to the Earth. Their gravitational forces pull in different directions, partially cancelling each other out. This creates neap tides, where the difference between high and low tide is at its minimum. The water's movement becomes more gentle, more subdued, a quieter, more restorative part of the cycle. As the tide continues its slow, methodical rise, the water now reaching your calves, think of the sheer volume of water being moved across the globe. This isn't just a surface phenomenon. The entire ocean basin is responding. The vertical difference between high and low tide is called the tidal range, and it varies enormously from place to place. In the open ocean, it might only be a foot or two. But in some coastal areas, the shape of the land acts like a funnel, amplifying the tide to incredible heights. The most extreme example on Earth is the Bay of Fundy in Canada. Here, the tidal range can exceed 16 meters, or about 53 feet. Try to picture that. Imagine the water level rising and falling the height of a 5-story building, twice a day, every day. Over 160 billion tons of seawater flow in and out of the bay with each tide cycle. That's more than the combined total flow of all the world's freshwater rivers. It is a display of planetary force so immense it's difficult to comprehend, yet it happens with the quiet reliability of a pendulum. And yet, even in this grand, ocean-spanning movement, there are points of perfect stillness. In the middle of the great ocean basins, there exist rare locations called amphidromic points. These are nodal points, like the center of a spinning wheel, where the water level barely changes. There is almost zero tidal range here. The great tidal bulges rotate around these quiet, tranquil centers, circulating through the ocean in a vast, graceful pattern. They are the calm, still heart of the ocean's rhythmic breath. Now, shift your awareness from the vertical rise and fall to the horizontal movement. The flow of water in and out of bays and estuaries is called a tidal current. As the tide rises, it creates a flood current, and as it falls, an ebb current. You can hear it now, a slightly deeper, more insistent murmur beneath the sound of the breaking waves. It is the sound of the ocean moving with purpose, pouring into the landscape. In some narrow straits, these currents can become astonishingly powerful, faster than a person can run, creating whirlpools and rapids not in a river, but in the sea itself. As the cool water swirls around you, consider this incredible, almost poetic exchange of energy. The friction of the tidal bulges dragging against the ocean floor is acting as a very gentle brake on the Earth's rotation. Every century, the length of a day gets longer by a tiny fraction, about 2.3 milliseconds. It's an imperceptible change to us, but over geological time, it is profound. But that energy doesn't just disappear. Through the laws of conservation of angular momentum, the energy lost by the slowing Earth is transferred to the Moon. The result? The Moon is pushed into a slightly higher orbit, moving away from us at a rate of 3.8 centimeters, about 1.5 inches every year. This is the same speed at which your fingernails grow. You are witnessing a slow, silent, gravitational conversation between our planet and its moon, a conversation that has been going on for eons, written in water and rock. And this dance isn't just on the surface. Far below you, in the dark, cold depths of the ocean, another kind of tide is moving. Where layers of water with different densities meet cold, salty water below and warmer, fresher water above the tides create enormous underwater waves. These are called internal tides, or internal waves. They can be hundreds of feet high, some of the largest waves on the planet, yet they move completely unseen, breaking silently against submerged continental shelves. They are vital. They act as giant, slow-moving spoons, stirring the ocean, mixing nutrient-rich deep water towards the surface, a critical process that helps fuel life in the sunlit zones above. The rhythm you feel on your skin extends down, into the blackness, into the very bones of the ocean. As the high tide now reaches its peak, a moment of tranquil stillness arrives. This is slack water. The vertical movement has paused. The horizontal currents have ceased. For a few minutes, the ocean holds its breath at the top of its inhale. The water around you is calm, deep, and quiet. The sounds are of the distant, gentle lapping on the shore. The air is heavy with the rich, mineral scent of the deep sea, brought close to the land. This is the peak of the cycle, a moment of fulfillment before the gentle, inevitable turn. Soon, the ebb will begin. The water will begin its long, slow journey back to the sea, and the entire process will reverse, a perfect, mirrored symmetry. The rhythm continues, in and out. Now, just feel that stillness, the quiet power, the patient energy, the deep and abiding peace of the tidal pulse. Let it become your own. The moment of slack water holds. This brief, sacred pause at the peak of high tide is a moment of absolute equilibrium. The vast machinery of the ocean has come to a gentle stop. The water around you is still, and the world seems to hold its breath. Then, almost imperceptibly at first, the shift begins. A subtle change in pressure, a new direction in the currents too deep to see. The great exhale of the ocean starts. The ebb tide has commenced. As the water begins its slow, deliberate retreat, it's as if a curtain is being drawn back, revealing a world that exists between two states of being. For thousands of years, humans have stood on shores just like this, watching this very same withdrawal and wondering. Long before we understood the physics, we felt the poetry. The ancient Greek explorer Pytheas, around 325 BC, was one of the first to document a direct link between the moon's phases and the height of the tides during his voyages to the British Isles. He saw the pattern, the connection, but the mechanism remained a profound mystery. Consider the Roman scholar Pliny the Elder, meticulously noting in his encyclopedia, Natural History, that the tides followed the celestial movements of both the moon and the Sunday. He wrote, "The ebb and flow of the tide are caused by the sun and moon, observing that the ocean swell was greatest at the new and full moon." These early observers were like listeners hearing a beautiful, complex piece of music, able to describe its rhythm and melody, but with no knowledge of the orchestra or the composer. For centuries, this was enough. For mariners and fishermen, the practical knowledge of the tide's schedule, passed down through generations or recorded in carefully guarded tables, was a matter of daily routine and safety. The famous tide tables for London Bridge, dating back to the 13th century, allowed ships to navigate the treacherous currents of the Thames, a testament to deep empirical knowledge. Yet, the question of why persisted. Even a mind as brilliant as Galileo Galilei's proposed an incorrect theory, suggesting the tides were a result of the Earth's rotation and orbit causing the oceans to slosh back and forth in their basins, like water in a shaken bowl. It was a mechanical, earth-bound explanation. The true answer, when it came, was far more grand. It arrived in 1687 with Isaac Newton and his Principia Mathematica. Newton's law of universal gravitation provided the key. He explained that every particle in the universe attracts every other particle with a force proportional to their mass and inversely proportional to the square of the distance between them. Suddenly, the tide was no longer just a mysterious rise and fall of water. It was the physical expression of a cosmic connection, a gravitational embrace between the Earth, the Moon, and the Sunday. At this very moment, as the water level drops further, you can see the first solid evidence of this cosmic law. The upper reaches of the rocks are now exposed, revealing a distinct band of life. This is the intertidal zone, a world born from the tide's rhythm. And this world is organized into layers, a biological map of endurance. The highest layer, the splash zone, is only wetted by the highest spring tides and sea spray. Here, dark patches of lichen cling to the rock, and tiny periwinkle snails, Littorina, dot the surface. These snails are master survivors. They can seal the entrance to their shell with a tough little door called an operculum, trapping moisture and allowing them to endure the sun and air for weeks, waiting patiently for the water's return. As we move our gaze downwards with the receding water, we enter the high tide zone. This area is submerged at every high tide but exposed for many hours a day. It is the kingdom of the barnacle. What looks like a field of tiny, sharp volcanoes is actually a dense colony of sessile crustaceans. Each barnacle has built its own fortress of calcium carbonate plates, cementing itself to the rock with a protein-based glue that is among the most powerful natural adhesives known to science. When submerged, tiny, feathery legs, called cirri, emerge from the top and rhythmically comb the water for plankton. Now, in the open air, they are sealed tight, a community holding its breath in unison. Descending further, the mid-tide zone is revealed, a place of richer, more crowded life. Here, dense beds of blue-black mussels, Mytilus edulis, blanket the rocks. Each mussel is anchored by a cluster of incredibly tough, elastic protein strands called byssal threads. Scientists are studying these threads to create new biocompatible adhesives for surgery. A single mussel is a powerful filter, capable of processing over 60 liters of seawater in a single day, clarifying the water and concentrating nutrients. Huddled among them are sea anemones. During high tide, they are beautiful, flower-like animals with waving tentacles. But now, exposed to the air, they have retracted their tentacles and pulled themselves into tight, glistening domes to conserve water. Some species, like the aggregating anemone, cover themselves with bits of shell and gravel, creating a natural sunblock. And now, the water has pulled back to reveal the low tide zone, the most diverse and vibrant part of this exposed world. Small, protected pools of water, or tide pools, have formed in the depressions of the rock. These are natural aquariums, temporary refuges for creatures that cannot tolerate exposure to the air. Here you might see a tide pool sculpin, a small fish perfectly camouflaged against the stone. This fish has an amazing ability. If the oxygen in its small pool runs low, it can actually gulp air from the surface. In another pool, a limpet holds fast to the stone. These conical-shelled mollusks are powerful grazers, using a tongue-like ribbon called a radula to scrape algae from the rock. The teeth on this radula are made of goethite, a mineral protein composite that is one of the strongest biological materials on Earth, stronger than spider silk. Many limpets will return to the exact same spot on the rock after feeding, a home scar that their shell has worn into the stone, creating a perfect seal to prevent drying out. The tide continues to fall, now revealing vast, glistening mudflats in the more sheltered parts of the bay. They appear barren, almost lifeless, but this is an illusion. The smell in the air, a faint scent of sulfur, is a clue to the intense activity happening just beneath the surface. This smell comes from hydrogen sulfide, a byproduct of bacteria breaking down organic matter in the oxygen-poor mud. This mud is one of the most productive habitats on the planet. A single square meter can be home to thousands of burrowing invertebrates, polychaete worms, tiny crustaceans, and nutrient-cycling clams. They are the hidden engine of the estuary, and their presence makes these flats an essential feeding ground for millions of migratory shorebirds that follow the tide's rhythm as a dinner bell. The tide is a shuttle, weaving back and forth between the deep sea and the shore. With each journey, it brings nutrients, and with each retreat, it reveals this world of incredible adaptation. Each creature, from the high-zone snail to the burrowing worm, has precisely timed its life to this lunar clock, this gravitational pulse. You are witnessing a world that breathes in and out once every 12 hours and 25 minutes, a community built upon the certainty of the water's return. And now, as the tide approaches its lowest point, the world is laid bare, quiet and waiting. The tide rests at its lowest point, a moment known as low water slack. The air is still, and the world of the shoreline lies exposed, quiet and glistening under the open sky. In this pause, we can truly appreciate the sheer scale of what has happened, but our minds struggle with such numbers, billions of tons of water, a rise and fall of dozens of feet. To grasp the essence of this power, it often helps to bring it down to a more human scale, to find comparisons in the world we know. Think of the entire tidal system as a planetary circulatory system. The great ocean basins are the heart, and the tides are the slow, powerful pulse that drives circulation. This pulse doesn't just deliver water, it transports heat, nutrients, and life itself, sending vital currents through the arteries and veins of coastal channels and estuaries. And just as with any circulatory system, sometimes this flow is funneled into a narrow passage, where its power becomes focused and dramatic. This phenomenon is called a tidal bore. Picture it this way. You are watching a river that flows gently towards the sea. But as the leading edge of the incoming tide arrives, it forms a single, continuous wave, or a series of waves that travels up the river against the current. It is the ocean's immense momentum concentrated into a solitary, moving wall of water. In some places, this is a gentle ripple. In others, it is an event of breathtaking force. The most powerful in the world is the tidal bore on the Qiantang River in China, known as the Silver Dragon. It can form a wave up to 9 meters, or nearly 30 feet, tall. This wall of water thunders upstream at speeds reaching 40 kilometers, or 25 miles per hour. The sound it generates precedes it by a long way, a deep, resonant roar that has been described for centuries. A similar phenomenon, called the pororoca, occurs in the Amazon River. The name comes from a local Tupi word meaning great destructive noise. This bore can travel an astonishing 800 kilometers, about 500 miles inland from the coast, a testament to the sheer, unstoppable force of the incoming tide pushing its way deep into the continent. It's like tilting a very, very large basin of water. The wave travels until its energy is spent. Another way to understand the tide's influence is to look at entire ecosystems that are built in its image. Move your focus to the warm, tropical coastlines, to the world of the mangrove forests. Here, trees not only tolerate the tide, they are sculpted by it. Picture a forest standing on stilts. These are the prop roots of the red mangrove, arching down into the mud to provide stability in the soft, shifting sediment. But what is truly clever lies in how they breathe. The mud here is anaerobic, meaning it has no oxygen. So, other mangrove species have developed specialized roots called pneumatophores. These are like biological snorkels, woody, finger-like projections that grow upwards out of the mud and water into the air. They are covered in tiny pores called lenticels that allow the root system to absorb oxygen during low tide. The management of salt is another challenge these trees have solved with incredible efficiency. Some species, like the red mangrove, are salt excluders. Their root membranes act as an ultrafine filter, blocking more than 90% of the salt in the seawater they absorb. Other species, like the black mangrove, are salt secretors. They take in the salty water and then excrete the excess salt through specialized glands on the surface of their leaves. If you were to look closely at a leaf, you might see tiny, glistening salt crystals, the byproduct of this constant, quiet work. What's happening here is more than just survival. It is construction. The intricate web of mangrove roots is exceptionally good at slowing down the flow of tidal water. As the water slows, it loses its energy and can no longer carry its load of suspended silt and sand. The sediment drops out and becomes trapped by the roots. Over years and decades, this process, called sediment accretion, literally builds new land. These forests are land creators, extending the coastline outwards, millimeter by millimeter, with every tide cycle. This service is so effective that mangrove forests are considered one of the most powerful carbon sinks on the planet, burying organic carbon in their deep soils at a rate much faster than terrestrial forests. This external rhythm of the tide has also been internalized by countless creatures. It's not just a clock they react to, it's a clock they carry within them. Consider the fiddler crab. At low tide, when the mudflats are exposed, the male crab's body darkens, making his oversized claw more conspicuous for courtship displays. At high tide, when he must hide in his burrow from aquatic life, his shell pales to a less noticeable, sandy color. Scientists discovered that even when kept in a laboratory with constant light and no tidal movement, the crabs continue this cycle of color change, precisely on schedule with the tides of their home beach. It is an ingrained, genetically coded rhythm. This internal timekeeping exists even at the microscopic level. On the surface of those same mudflats, a golden brown film may appear as the tide recedes. This is made of millions of diatoms, a type of single-celled algae. To avoid being washed out to sea, these diatoms, such as the species Hanskia virgata, burrow into the top few millimeters of mud during high tide. When the tide is out and the sun is shining, they migrate to the surface to photosynthesize. This vertical migration is perfectly timed to the 12-4-hour tidal cycle, governed by their own internal clock. This synchronization can also be reset. Think of it like adjusting your watch after a long flight to a new time zone. When oysters are moved from one coast to another with a completely different tidal schedule, they will, for a time, continue to open and close their shells to feed according to the rhythm of their original home. But over the course of about 2 weeks, they will gradually but surely resynchronize their feeding behavior to the new local lunar clock. Perhaps the most precise and dramatic example of this biological timing is the spawning of the California grunion. For a few nights following the highest high tides of the spring and summer, thousands of these small silvery fish ride the waves onto the beach. The females wriggle their tails into the wet sand to lay their eggs, and the males deposit their milt around them. Then they all catch a receding wave back into the sea. This entire event lasts only a few minutes. They lay their eggs at the highest reach of the tide, so the eggs will remain relatively dry and safe from marine creatures, incubating high up on the beach. 2 weeks later, the next set of spring tides, higher than the intervening neap tides, will wash over the nests just as the eggs are ready to hatch, carrying the new generation out to sea. It is a reproductive strategy so perfectly aligned with the lunar and tidal cycles that it appears as a form of natural prophecy. It is a reminder that the great, slow breathing of the ocean is not just a physical process, but the metronome for life itself. And now, the low tide slack is ending. a new pressure builds. The turn is coming. The ocean prepares for its next deep inhale. The stillness of low tide is broken. Far out, a new pressure is building, a subtle yet irresistible force. The flood tide begins. The ocean starts its long, slow inhalation. A small wavelet, the first messenger of the returning sea, slides over the wet sand, a little higher than the last. The great cycle, the fundamental rhythm we have been observing, is turning once more. As the water begins to reclaim the shore, let's widen our perspective. We have seen how the tides shape coastlines and synchronize the lives of countless species. But this gravitational pulse from the moon has played an even more fundamental role in the story of life on Earth. Its influence may be one of the reasons we are here at all. Picture the early Earth, billions of years ago. The moon was much closer then, perhaps only 25,000 kilometers away, compared to the nearly 400,000 kilometers today. Because of this proximity, the gravitational pull was immensely stronger. The tides on primordial Earth would have been colossal, monstrous waves of water perhaps hundreds of meters high, sweeping far inland and then receding over and over. Now, imagine the first sparks of life, simple chemical compounds in the shallow primordial seas. These tides would have created an endless cycle of wetting and drying in vast coastal zones. One recent scientific hypothesis suggests this repetitive action was a crucial ingredient for life's origin. The cycle of hydration and dehydration in these tidal pools could have provided the perfect conditions for simple organic molecules to link together, forming the longer, more complex chains like RNA and proteins that are the building blocks of life. The tide, in this view, was not just a stage for life, but a catalyst, a vast planetary machine that helped stir the chemical soup into existence. This deep connection between the lunar cycle and biology is not just a distant memory from our planet's past. It resonates within us, in ways we are only just beginning to understand. For millennia, cultures have associated the moon with fertility and life cycles. While many of these are myths, modern science has found some surprising correlations. For instance, in certain coral species, their annual mass spawning event is timed with breathtaking precision. On Australia's Great Barrier Reef, over 130 coral species will release their eggs and sperm into the water column simultaneously, on a specific night in late spring, a few hours after sunset, following a full moon. This synchronized release, triggered by lunar cycles and water temperature, maximizes the chances of fertilization. It's an entire ecosystem participating in a single, coordinated act of renewal, all cued by the light of the moon. Deep within your own body, similar rhythms are at play. Your entire physiology is governed by internal biological clocks known as circadian rhythms. These cycles, which run on a roughly 2 4-hour schedule, regulate your sleep-wake cycle, hormone release, and metabolism. While these are primarily tuned to the daily cycle of light and dark from the sun, recent studies have begun to find evidence of other, more subtle rhythms. Some research has shown faint but measurable patterns in human sleep and cardiovascular function that seem to correlate with the 29.5-day lunar cycle and the 24 8-hour lunar day. It's a highly debated and cutting-edge area of chronobiology, but it suggests that our ancient connection to the moon's rhythm may not be entirely lost, but simply buried deep beneath the more dominant solar day clock. As the water continues to rise, it resubmerges the world we saw exposed just a short time ago. The tide pools, once isolated, are now reconnected to the ocean. The limpets and sculpins are no longer in a temporary refuge. They are part of the sea once more. Notice how the mussels, which were sealed tight, have now opened their shells slightly. Their byssal threads hold them fast against the growing current, and they begin their work of filter feeding, clearing the water. Their small, continuous effort is a vital part of the bay's health. In a year, a single square meter of a healthy mussel bed can filter the water volume equivalent to a 2-5-meter swimming pool every 4 days. The water now covers the barnacle-encrusted rocks. If you could look closely, you would see the tiny doors of each barnacle slide open. Their feathery cerci emerge, unfurling like delicate hands to sweep the water, rhythmically combing for microscopic plankton. They are like a city that has woken up, its million residents all reaching out to gather their sustenance from the flowing currents. This is the tide's gift, a delivery service. For sessile, or stationary creatures, the tide is everything. It is their source of food, their method of dispersal for their young, and the current that clears their metabolic waste. They have traded mobility for the certainty of the tide's provision. The rising water brings a change in the sensory environment. The sounds of the gulls and the shorebirds become more distant. They are replaced by the sound of water, a deeper, more resonant sound now. It's the gurgle and slap of waves against the newly covered rocks, the low hum of the current. The scent in the air also shifts. The sulphury smell of the low-tide mudflats is washed away, replaced by that clean, invigorating brine. The temperature of the air near the water's surface cools slightly, a gentle reminder of the immense, cold mass that is now moving in. This incoming tide is not just water, it's an infusion of oxygen. As waves break and the surface is agitated, atmospheric oxygen is mixed into the water. This process is essential for the health of all the aerobic organisms in the nearshore environment. It's a literal breath of fresh air for the entire ecosystem. And consider the energy. We often think of harnessing the tide's power as a modern invention, with tidal barrages and underwater turbines, but nature has been doing it for eons. The simple act of moving this water creates an enormous amount of kinetic energy. The total energy dissipated by tides across the globe is estimated to be about 3.5 terawatts. To put that in perspective, that's roughly twice the world's total electricity consumption at any given moment. Most of this energy is simply converted into heat through friction with the seabed, gently warming the ocean basins in a slow, planetary scale process. The water is high on the shore now, lapping at the same marks it reached just over 12 hours ago. The periwinkles in the splash zone feel the first touch of moisture, a signal that their long wait is over. The cycle is nearly complete. The tide's rhythm is a bridge between the cosmic and the biological, between the moon and the microbe, between the ancient past and the present moment. And it is a bridge within you, connecting the conscious, thinking part of your mind with the deep, ancient, rhythmic processes of your own body. As the tide reaches its full height once more, feel that connection. Feel the quiet certainty of the cycle, the reliability of the rhythm, and the deep, restorative peace that comes with it. The water is at its peak once more, high tide, a state of fulfillment. The cycle has completed, and the shore rests, submerged and quiet, under a deep blanket of cool, clear water. From our vantage point, the ocean appears uniform, a single entity. But let's refine our focus now to the unseen world carried within the tide, the microscopic life that is the true engine of the sea. Imagine you could shrink down, becoming a passenger on the currents. The water that feels so smooth against your skin is, at this scale, a rich and complex soup. It is teeming with plankton, a term that comes from the Greek word planktos, meaning wanderer or drifter. This name is perfect, as these organisms cannot swim against the currents. They are carried along by the ebb and flow of the tide. Plankton is not a single species, but a vast community divided into two major groups, phytoplankton and zooplankton. The phytoplankton are the plants of the sea. They are microscopic, single-celled algae and bacteria that, like plants on land, use photosynthesis to convert sunlight into energy. A single liter of coastal seawater can contain over 1 million of these tiny organisms. The most common types are diatoms and dinoflagellates. Diatoms, which we encountered earlier on the mudflats, build intricate, beautiful shells of silica, essentially glass, called frustules. There are over 100,000 known species of diatoms, each with a unique jewel-like structure. These glass houses are not just for protection, they help the diatoms to regulate their buoyancy, sinking and rising in the water column to find the perfect balance of light and nutrients. Dinoflagellates are another key group. Some of these have two whip-like tails, or flagella, that they use to move through the water. While some dinoflagellates are photosynthetic, others are mixotrophs, meaning they can both photosynthesize and consume other organisms. One of the most enchanting characteristics of certain dinoflagellates, like Noctiluca scintillans, is bioluminescence. When the water is agitated, a chemical reaction within their cells produces a flash of cold blue-green light. A wave breaking at night, or the trail of an oar through the water can ignite thousands of these points of light, creating a truly magical spectacle. This light is a form of communication, and perhaps a way to startle would-be grazers. The collective work of all phytoplankton is staggering in its importance. They form the base of nearly all marine food webs, but even more critically for us, they produce a massive amount of the oxygen we breathe. It is estimated that phytoplankton are responsible for between 50 and 80% of the oxygen in Earth's atmosphere. Every other breath you take is a gift from these microscopic drifters in the sea, delivered by the planet's immense circulatory system. Riding the currents alongside the phytoplankton are the zooplankton. These are the animals of the plankton world. They range from single-celled organisms like foraminifera, which build beautiful chambered shells of calcium carbonate, to the larval stages of much larger animals. The tiny, almost transparent creature you see might be a copepod, a small crustacean with long antennae that is the most abundant animal on Earth by biomass. Another might be the larval form of a barnacle, a crab, or a fish. For these creatures, the planktonic stage is a journey of dispersal. The tides and currents act as a free transport system, carrying them far from their parents to settle in new territories. This process ensures genetic mixing and the colonization of new habitats. One of the most remarkable behaviors in the ocean is driven by this zooplankton community. It is called diel vertical migration, and it is the largest migration on Earth by total biomass, happening every single day. As dusk approaches, vast armies of zooplankton and the small fish that feed on them begin to ascend from the dark, deeper waters where they have spent the day hiding. They travel hundreds, sometimes thousands of feet upwards to feed on the rich buffet of phytoplankton in the surface waters under the cover of darkness. Then, as dawn approaches, they descend once more into the deep, a daily, synchronized movement of trillions of organisms. This migration acts as a biological pump, transporting carbon captured by the phytoplankton at the surface down into the deep ocean, where it can be stored for long periods. It is a critical part of the global carbon cycle, a planet-regulating service performed by creatures too small to see. Now, as the tide begins its slow turn towards ebb once more, let us consider the sounds of this world. The ocean is far from silent. The sound we associate with the sea, the crash of waves, the shush of water on sand, is just the surface noise. Beneath the waves, the soundscape is rich and varied. The snapping shrimp, for instance, creates one of the loudest sounds in the ocean. It has one oversized claw that it can snap shut so fast it creates a cavitation bubble. When this bubble collapses, it produces a loud pop and a flash of light, a phenomenon called sonoluminescence that can stun small prey. A whole colony of these shrimp can create a continuous crackling sound, like bacon frying, which can actually interfere with sonar systems. Fish, too, communicate with sound. Many species use their swim bladders, the gas-filled sac they use for buoyancy, as a drum, vibrating it with special muscles to produce grunts, croaks, and hums used in courtship and territorial disputes. The collective sound of a reef can be a constant hum and crackle of life. And over all of this, the low-frequency sounds of the Earth itself can travel for thousands of miles through the water, the rumble of distant underwater earthquakes, the songs of whales, and even the groan of shifting sea ice. The tidal currents themselves generate a low-frequency hum as they move over the contours of the seafloor, a constant deep note in the ocean's symphony. And what of the chemistry? The tide's rhythm constantly adjusts the chemical balance of the coast. For example, the pH, or acidity, of the water changes on a daily cycle. During the day, as phytoplankton and seaweeds photosynthesize, they absorb carbon dioxide from the water, which makes the water more alkaline, a higher pH. At night, when photosynthesis stops but respiration continues, CO2 is released, making the water slightly more acidic. The tide layers another rhythm on top of this, bringing in water from the open ocean with a more stable pH, then receding and allowing the local biological processes to dominate again. The tide has turned. The ebb current begins to pull. The plankton, our tiny fellow passengers, are now on a return journey, being drawn away from the shore out towards the open sea. Some will be consumed, some will complete their life cycle, and some will be carried to new shores. Their journey is one of chance, guided by the immense, reliable, and utterly indifferent physics of the moon and the earth. To be a plankton is to be in a state of complete surrender to the flow. It is to trust the current, and as the water recedes, it leaves behind a world refreshed, reoxygenated, and ready for the quiet period of low tide to come. The grand, slow process continues, a rhythm within a rhythm, from the cosmic to the microscopic, all in perfect, silent harmony. The tide has turned. The ocean begins its great exhalation, the long, slow process of the ebb tide. The water, which had reached its highest mark, now begins to recede, drawing its watery cloak back from the land. This is a time of transition, a slow and graceful retreat. Our journey of observation is drawing to its natural, peaceful close. As the water level drops, the process we saw before unfolds in reverse. The highest rocks of the splash zone are the first to be left behind, glistening and dark. The periwinkle snails, having enjoyed their brief submersion, seal their shells, prepared for the long, dry hours ahead. Then, the zone of the barnacles is exposed. Their feathery cerri retract, their protective plates slide shut, and a community of thousands falls into a coordinated state of rest. This is a world shutting down, step by step, in perfect time with the lunar clock. Notice the sounds changing. The deeper gurgle of high tide is replaced by the gentle trickling of water draining from rock crevices. The sound is softer now, more intricate. It's the sound of letting go. A final, small wave sighs against the shore, and then the next one is just a little further away. The energy is withdrawing. The immense kinetic force of the flood tide is dissipating into a calm and quiet potential. Deep within the ocean, this change is felt in a different way. The tidal currents that stir the water column begin to slow. The vertical migration of zooplankton has reversed, with trillions of tiny creatures descending back into the quiet, stable darkness of the deep. In these abyssal zones, the world is almost timeless. Temperatures remain incredibly stable, often varying by less than half a degree Celsius over an entire year. It is a world of immense calm, a sanctuary of stillness far removed from the dynamic surface. It is a place of profound, deep rest. And so, we bring our observation of the outer world to a gentle halt. We have witnessed the grand cosmic dance and the intricate, microscopic lives that follow its rhythm. Now, it is time to turn our awareness inward, to discover this same ancient rhythm within you. The cycle of the tides is a perfect metaphor for the cycle of sleep. Your waking day is like the high tide. It is a time of energy, of engagement with the world. Your senses are flooded with information, your mind is active, your body is in motion. It is a time of doing, of creating, of interacting. This is a vital and necessary phase full of life. Then, as evening comes, the ebb tide begins within you. This is the process of winding down. It is the gentle, step-by-step release of the day. First, the demands of the outer world recede. The emails are sent, the work is done, the conversations end. Then, the inner world begins to quiet. The pace of your thoughts begins to slow. The concerns of the day lose their sharp edges, softening and drifting further away, like objects carried out on the receding water. This is a gradual process, a slow and easy release. There is no need to force it, just as the ocean does not force the tide. It simply happens. The moment of low tide slack corresponds to the threshold of sleep, a quiet pause where the mind is no longer pulling in or pushing out. It is a state of equilibrium, a peaceful stillness between the waking world and the world of dreams. And then, you enter the deep, low tide of sleep. This is the period of profound rest and restoration. Just as the tide pools are isolated and still, your consciousness withdraws from the external world. And just like the unseen internal tides mixing the deep ocean, your mind and body are performing their own quiet, essential work. Memories are consolidated, shifting from short-term to long-term storage. Cellular repair takes place. The nervous system recharges. This is a time of deep internal renewal, happening all on its own, far below the surface of your awareness. Your breath is your own personal tide. Feel it now. The The gentle rise of your chest on the inhale, a small flood tide, and the slow, easy fall on the exhale, a gentle ebb tide, in and out. A simple, reliable rhythm that has been with you every moment of your life. There is nothing you need to do to control it. Simply notice it. Feel the air, cool as it enters and warm as it leaves. This is the rhythm of life, the rhythm of rest. As you rest here, allow the feeling of this rhythm to be your anchor. Each exhale is an opportunity to release, to let go just a little bit more. Let go of the need to think. Let go of the need to plan. Let go of the tension in your muscles. With each breath out, you can feel your body becoming heavier, more settled, more deeply at peace. Your body knows how to sleep. It is an ancient, innate wisdom. You do not need to teach it how. You only need to provide the quiet and the stillness for this wisdom to unfold. You can trust this process completely. The day is complete. Its purpose has been fulfilled. The night is a time for quiet restoration. It is safe to rest now. It is safe to let go. Your mind can be still. Your body can be heavy. Every breath out is a wave, carrying you further into quiet. Every exhale softens the edges of the world. There is nothing to do. There is nowhere to be. Only here, in this moment of deep peace. Your body is restoring itself. Your mind is clearing itself. This is a time of profound healing. You are supported. You are secure. You are drifting on a calm, quiet sea of sleep. The rhythm of your breath is the rhythm of the ocean. Slow and deep and peaceful. Allow your awareness to soften. Allow your thoughts to dissolve like salt in water. You are entering a space of deep, effortless rest. The gentle pull of sleep is as natural as the pull of the moon on the sea. You can surrender to its peaceful gravity. Rest now. Sleep now. Good night.